Alright, machine learning. Imagine a world where computers can learn from experience, adapt to new information, and make predictions, just like humans. Some time ago, this sounded very futuristic, but well, it's happening right now, and thanks to machine learning. From Google search results to facial recognition and spam filters, machine learning is all around us. But what exactly is it, and how does it work? By the end of this video, you will understand the basics of machine learning, its types, applications, and even some of the most common algorithms. But before we dive in, let me introduce myself. My name is Juma Shafara, and I'm a data scientist at Raising the Village, an instructor at Data Idea, and this year I set out to help people become data scientists by covering data science concepts in a simple and intuitive way. I have a roadmap linked in the description where we begin from the Python basics, and in this section we shall introduce ourselves to machine learning, first with this simple presentation, and then we shall have a practice session where we build a music recommender. So what is machine learning? Machine learning is a science of teaching computers to learn from data without being explicitly programmed. This is the definition according to Arthur Samuel, who also coined the term machine learning in 1959 while he was working on a checkers playing program. He was a game developer, and what he wanted to do was to have the computer just learn from its mistakes and play as if it were human. Later, Tom Mitchell provided a formal definition stating that a machine learns if its performance on a task improves with experience. This concept was also inspired by Alan Turing's early work on artificial intelligence. What are the types of machine learning? There is supervised machine learning. Here, the model learns from labeled data. For example, email spam filters learn from labeled spam or not spam messages. Okay? The other part is supervised machine learning. Under supervised machine learning, the model finds hidden patterns within the data without labels. A good example is customer segmentation in marketing. The other type is reinforced learning, where this works through rewards and penalties, just like training a pet. Think of how self-driving cars learn to navigate roads. Okay. Now, lastly, we have semi-supervised learning, where this is a mix of both. The model trains on a small amount of labeled data and larger sets of unlabeled data. Applications of machine learning. So machine learning is applied in search engines like Google and Bing. Use machine learning to rank results based on what's most relevant to you. Photo tagging, Facebook, Instagram use facial recognition to suggest tags for your photos. Also, machine learning is applied in spam detection, where Gmail, for example, uses machine learning to filter out unwanted emails automatically. Now, before we train a machine learning model, we need to process some data properly. There are a few techniques, and even though some of these look a bit technical, they are really simple concepts, and in future we shall learn how to implement them. The first one is rescaling and standardization. Here we are adjusting the data to fit within a common range for easy interpretation. The other one is normalization and binarization, where we structure data just for better analysis. One other important technique we may use is label encoding, where we convert categories into numbers for machine learning to understand, because machine learning models and computers work very well with numbers as compared to words. What are the common machine learning algorithms? There are very many machine learning algorithms out there, but the most common ones include like linear regression, which is used for predicting continuous values, like house prices. And then there is logistic regression, which is great for classification problems like spam detection. There is also a decision tree, which is a simple model that splits data into decision nodes, like how a flowchart is. So like basing on this, what should we do, basing on this, and so on. The other one, which will be the final one in this context, is a support vector machine, which optimizes classification by finding best decision boundary. So here is like if we have a basket of fruits, this algorithm just tries to find the best boundary between, say, apples and oranges. There are some pros and cons to machine learning, and beginning with the pros, machine learning is very handy as it is able to identify hidden patterns and trends within our data. We can use machine learning to automate repetitive tasks. Also, machine learning works with complex data structures, so it makes working with complex data structures really, really easy. However, some of the cons of machine learning are that it needs usually large and high quality datasets to learn, even though these days there are some techniques and algorithms that have been developed so that you can use even a small dataset to learn some useful patterns. Many times, some of these models, for example, the ChatGPT, they require high computation power, and also they can take a very long time to train. Machine learning models can also be biased sometimes. This is especially if they are trained on some flawed data that is not very, very proper. Okay, now here is the thing. If you found this video helpful so far, okay, don't forget to like, share, and subscribe. In next section, let's practice how to build a machine learning model. Alright, so we'll train a decision tree classifier on this dataset and see machine learning in action. We'll be using Python and scikit-learn to predict music preferences based on age and gender. Before we dive in, this is just a simple dataset that I wanted to show you where we have age, gender, and genre. It's really, really simple. And also, I wanted to show you Google Colab. This is the ID that we shall be using to train our model. You can just find it on Google. So if you just search on Google Colab, this first result is where you want to go. Okay, when you click on this, it will take you on Google's website, and you just want to click New Notebook. So once you click on New Notebook, it will open up a new notebook, which will just look exactly like this one. Okay, once we are done with that, we can upload our dataset, okay, by using this icon, and then we can select the dataset that we want to work with. Okay, now our dataset has been uploaded. Okay, quickly we can begin to write some code. Okay, so we can add this cell. Usually it is existing already, but if you don't see it, you can just click on plus code to add this cell. And here we shall import some few libraries that we shall be using. Maybe let's just import one to load our dataset. So let's import pandas as PD. Okay, and then we can run. To run, we can do shift enter, and then we can import our dataset by saying data is equals to pd dot read CSV. This one is a comma separated file. This is how we read a dataset. More on datasets is in my pandas crash course. Okay, then we want to just read music dot CSV. Simple, like that. When we are done, we can look at the top part by doing data.head. Again, this is all in the pandas crash course, so we can see the top 5 values in our dataset. Okay, let's prepare this data for training. For now, we just want to set out, we shall be using supervised learning. So for our algorithm, we shall tell it what are the true values and which data will be contributing to that. So the way we do that is by setting x, which are the features or contributing factors, as data dot drop. So from the data set, if we remove genre, we remain with only the two other contributing columns. So we can do dot drop columns, then we say genre, like that. Now we can set the target, which is the outcome, okay, as data dot genre. Okay, really simple. Next, we want to split our data into training and test sets. So this is important because once we are done training our model, we want to see how it's been performing or its performance. We shall use the 80 to 20% technique for now. So we can do this by saying from sklearn dot model selection import train test split. Okay, after doing that, we shall say x train, okay, and then x test, and then y train, and finally y test are equal to test train test split. Okay, this is a function, so we call it, and then we pass in our x, the feature set. Also we can pass in y, the target. Then we can pass in the test size. The test size here refers to how much of our data set we want to use for testing. Okay, so we can put 0.2 to represent 20%. And then we can also add an optional parameter called random state, which is just for reproducibility, but it's very, very optional. Okay, and then we can run that. Now we have our data split into training and testing sets. Okay, now from now we can go ahead and train our model. The way we shall do that is we shall say, first of all, we shall import our model from sklearn. By doing like this, we say from sklearn dot tree import decision tree classifier, like that. Now that we have our decision tree classifier, we can instantiate it and fit the algorithm. So we shall say decision tree classifier. I'm just using DTC to represent our, or maybe let me just say model is equals to decision tree classifier, like this. This is how we instantiate our model. And then we can train our model by using model.fit. Simple, like this. It's really, really simple. Then to fit, we shall pass in the feature set for training and the target for training, like this. X train and Y train. It's simple, like that. Okay, now once we run that, our model has been trained. Okay, so we can make predictions, for example, by saying predictions are equal to model dot predict. It's simple, like this. This is how we make predictions. It's very, very simple. So we can predict the X test, okay, like that. And for now, we can just print out the predictions and then we see what we have. So for the X set, okay, we have hip hop. For, let me just print out also, let's first also print out the X test and then we see what we have here. So what we have here is that for a person of age 20 and gender 1, their prediction was hip hop. For a person of 35 years and gender 0, female probably, is classical, likes classical music, and so on and so forth. Here, for example, for a person of age 23 with gender 1, they like hip hop. Okay, it's very simple, like that. Now the final part is to evaluate our model, to see our model performance. We can do this by using the accuracy score from sklearn. So we can do sklearn from, let's say from sklearn dot metrics import accuracy score. Okay, simple like that. Now accuracy score is a function that we can call and pass in the true values and the predicted values. So we shall just say accuracy, for example, is equal to accuracy score, okay, and then we open brackets, then we pass in y test, okay, and then the predictions. Simple like that. Then we can print out the model accuracy. For this case, if I run this, we get 1. Now for this example, the model scoring 1 means that it has completely learned the data. The higher accuracy usually means better performance. This is not entirely true sometimes, and we shall always check in future how to validate on other metrics to see the performance of the model. Maybe before we close off, I just wanted to show you that the model that we have trained here, we can also share it with other people or deploy it, okay, so that other people can be able to use it. And with the way we do it, there are very many ways, but for now I just want to show you that we can save this model as a file. So the way we can do that is we can say import joblib, okay, and then we can run. So from joblib we want to use a function called dump, okay, and the way this works is we can say joblib dot dump, okay, and then we can pass in the value that we want to dump. Dump basically means, you know, creating a file. So the value here will be the model, okay, and then the file name, we also pass in a file name, which is basically the path to where we want to save the model. So for now we can just, you know, save it as maybe music recommender dot joblib, okay, simple like this. When we run this, we shall see in our file explorer section we have our model saved as music recommender dot joblib. This model, you can download this file, okay, and then share with another person. Once you've shared with another person or even with yourself, you can be able to now load your model by saying joblib dot load, okay, and then you can pass in the file name of the model. The file name or the path to the model in this context is music recommender dot joblib, okay. So this one will load our model, and you can store this in a variable, for example loaded model. Alright, so after loading your model, you can again use this model to make predictions. For example, I can make predictions for this particular person that has maybe 20 years and is maybe male. So I can say, for example, loaded model dot predict, okay, and then I can predict on, for example, a person that has 20 years and maybe they are male, okay, and this one is hip hop. Okay, we have some little warning here, but I'll cover this one later. Okay, I'll just say this little warning is simply because when we're training our model, these values had been labeled as age and gender, but here we're not labeling them. That's why, but it's not a thing to worry about. What we want to take away is that the prediction has been made, okay. You can also make a prediction on many items. For example, we can say loaded model dot predict, okay, x test, and we can still store these ones in maybe we can say loaded model predictions, and we can print these ones also out, okay, and then we shall say that they are identical to the ones from the model that we had just trained, okay, because it's the same model. We just loaded it from a file. All right, at this point, we've learned how we can train a decision tree classifier to predict music preferences. Again, if you found this very helpful, hit like, subscribe, and comment your thoughts below. So stay curious and let's keep learning, and see you in the next tutorial. Thank you, bye.